what if we could collect sunlight in space and send that energy down to Earth? It sounds like science fiction, but engineers are seriously exploring this idea. Here on Earth, solar panels convert sunlight directly into electricity, but they only generate power when sunlight reaches the panels. This process fuels our world with clean energy. The challenge is simple. Earth rotates. When your location is facing away from the sun, solar panels cannot collect sunlight, so energy production stops. Clouds, storms, and changing weather can also reduce solar power production. So what if we could place solar collectors somewhere above all these problems? That is the basic idea behind space-based solar power. Collect sunlight in space, where sunlight is available for much longer, and then deliver the energy to Earth. A space-based solar power system would use a large satellite covered with solar panels. The satellite would collect sunlight and convert it into electrical energy. In space, the satellite can receive sunlight without being affected by nighttime at the same location or by most weather conditions in Earth's atmosphere. Depending on the orbit and system design, a space solar platform could collect sunlight for much longer periods than many ground-based solar installations. But collecting sunlight is only half the challenge. The energy must somehow be transmitted from space down to a receiving station on Earth. One proposed solution is wireless power transmission, using technologies such as microwaves or other directed energy methods to send power across the distance. The complete system has several steps. Collect sunlight in space, convert it into electrical energy, transmit that energy to Earth, and finally connect it to the electricity grid. The first stage uses voltaic cells, similar to solar panels on Earth. These cells convert incoming sunlight into electrical power. Power electronics would then condition, and prepare the electricity for transmission. This step is essential for efficiently moving energy from the satellite toward Earth. One proposed method uses microwaves. The satellite would convert electrical power into electromagnetic energy and direct it toward a receiving station on Earth. On Earth, the receiving system could use an array of antennas, sometimes called a rectenna, to capture the transmitted energy and convert it back into electricity. After receiving the energy, the electricity could be processed and connected to the existing power grid, supplying electricity to homes, businesses, and industries. To generate significant amounts of electricity, these satellites could be enormous. Building and deploying such large structures in space would be a major engineering challenge. Future systems may require advanced robotics to assemble and maintain large structures in orbit, reducing the need for humans to perform every dangerous task in space. Another challenge is transportation. Large amounts of equipment and materials must be launched into space, so reducing launch costs is critical to making the concept economically practical. Space systems must also be maintained. Robots or specialized spacecraft may be needed to repair components and keep the solar station operating for many years. The biggest potential advantage is consistent energy generation. Space-based solar power could provide electricity during periods when ground-based solar panels are producing less energy. Space-based solar power would not necessarily replace renewable energy on Earth. Instead, it could potentially complement solar, wind, batteries, and other energy technologies. In the future, space-based power could potentially support remote locations where building traditional energy infrastructure is difficult or expensive. But there is a major obstacle: cost. Building, launching, assembling, and maintaining giant power satellites could require enormous investments. Efficiency is another challenge. Every step, from collecting sunlight to transmitting and receiving the energy, must be highly efficient to make the system worthwhile. Space debris and safety must also be considered. Large structures in orbit need protection from debris, and any energy transmission system must be carefully designed and controlled. Making space-based solar power practical may require breakthroughs in reusable rockets, lightweight materials, robotics, power electronics, and wireless energy transmission. Imagine a future energy network where solar power comes from both Earth and space, supported by batteries, smart grids, and advanced energy technologies working together. The big idea is simple. Collect sunlight in space, convert it into electricity, transmit that energy to Earth to where it is needed. The potential is enormous. Space-based solar power may still be years away from becoming a major source of electricity, but it represents a bold idea for the future. Engineers can overcome the challenges. Thanks for learning with Ethan. If you enjoyed this lesson, don't forget to like, subscribe, and turn on notifications so you never miss another easy-to-understand engineering video.